What's up everyone, this tutorial is inspired by the UFO 50 paint racer game, and as you see we can paint around the game and we try to go over the red ones, and we can also drive over the cars and destroy them. And so this is just the basic prototype of the paint racer game. As you see, you have collisions and everything, and then we can't drive into walls. There's a little collision detector for that as well. Now let's get started. Alright, as always, we're going to start a new project with a 2D, node 2D. We're going to call that world, and then immediately we're going to put our tile map in here, and that is going to be our grid. And so we can save world, and I'm going to import those files, so give me 1 second. Alright, so I have my files imported for my paint racer, and we're going to go ahead and set up our tile set. So we're going to go here, create a new tile set, go in here and click on tile set down here, and we're going to go ahead and drag some files in. So a couple things we want the grid, automatically do it. We want the block, automatically do that. We want the blue paint, automatically do that. And we also want the red paint. So drag those all in. Let's set up also our window. So we want to do 480 by 270, and then we want to change it to viewport, and we're going to integer here. Save that. That should be good enough for now. Go over to tile map, click on the grid, click this. We want to drag it within our whole viewport. Let's click off of it to see how much more we need. We apparently missed quite a bit, so let's fill in the whole blue square. Start from this corner, select the grid again, drag it over to that corner, save. We can go and start the current scene. This is what our scene would look like. Awesome. Now let's go to our back to our tile map. Click on the block, and we want to go here and draw the line on the edges. This is what we'll do for now, along the edges. So we're just setting up our little arena for now, and we can just draw some lines like so. And to create physics collisions, we need to go in and set a collision layer. So physics layer, so inside of our tile set, physics layer, and add one. And then we can go back to our tile set, click on the block. Click here, go to paint, and then we want to go to physics layer, and you'll be able to paint it. It should be all set up for you like so. Alright, let's go run our thing. There you go. We got our little arena for now, and let's create a new scene. This scene will use an area 2D, and let me make sure I'm referencing this properly so we don't mess up. So we will have our area 2D will be called player, and we will add a sprite 2D, as well as a collision shape 2D. Now, not as a child of the sprite 2D. And then lastly, a raycast 2D. Okay? Save our player scene, go and drag in our car. And we can have the car sprite be centered. Alright. Here. Oh, one last thing we forgot to do on our rendering is to go back to our project settings, hit textures, and we need to change this to nearest. That will sharpen up our image for us. Okay. Go to our collision shape. And we want to have a square rectangle. Instead of 20 by 20, we'll set the pixels 14 by 14. Now this car is a little bigger than that, but for this we'll make sure that we're not going to be colliding with other squares outside of our grid, which is going to be 16 by 16 on our grids, on our little tiles. And so they'll set it there. And then we can start our player script. Alright, so our player script will have an onReady function. So what we can do is, not onReady function, but we want to address our onReady, so we can control click these, drag them in. I keep messing this up. Control click and drag in, and that will auto do it for us, but you can also type in at onReady var sprite2d and then $sprite2d. Okay? We also want at the beginning to have a var export variable var map, and it will be a type of tile map. So it won't be set to anything now, but we'll import it and be able to connect to our tile map. Then we want to have a animation speed. This will be used for our team for movement from grid space to tile to tile. We'll have a moving check. This allows us to not keep moving while we're in the midst of moving from tile to tile. Okay? And then lastly, we want to also have what's called a var tile size, which is 16. And then we can also have inputs, and this will allow us to determine our inputs. So we want right, vector2 right, and keep going. We just go left, and this is called a dictionary is what we're doing here, and we're having a property of right and a value of a vector2 right, and the same thing with the left. We'll keep doing that with each of our inputs. So we'll have an up input, and that will have a vector2d property of up, and then keep going down, and they'll have a vector 2D of down, and lastly stop, which will have a vector 2, I keep saying 2D, a vector 2 of 0. Alright, so we have this all set up now. We could move this over and click left on all those. Center it looks a little bit nicer. Now, one last thing that we want to keep track of is the last input direction. So last input, oh my gosh, cannot spell today. Direction is equal, and we're just going to be doing the value, the property name stop. All right. Now, one thing we have to do is go to our project settings and add these into our input map. So we have up, down, left, right, and stop. And I'm going to have up be the up arrow, down be the down arrow, the left be the left arrow, and right be the right arrow, and lastly, stop will just be spacebar. We could change these if you like, but for now, that's what I'm going to use. And then on our onReady function, we want to position equal to position snapped. It's vector 2.1 times tile size, and then position plus equals vector 2.1 tile size, not spell, divided by 2. Oh, I meant to make this multiplied. All right. Now we need to create a couple functions. So we want to handle our input. So func underscore input, oh, not init input. And we want to do for direction and input dot keys. It says if event is action pressed, and that is the type of direction. Then we want last input to equal direction. Okay. Let's see if I can type this right. Yep, we're all good. All right, now let's handle our movement. So you want to do func move, and that will intake a direction. And we'll have our current cell. I don't even, no, we don't need current cell right now. We need to change the target of our raycast. So we'll do raycast2d dot target position is equal to inputs and then direction. I'm not die, direction times tile size. All right. Ray force, not update, but we want force. Oh, I'm not typing this right. Okay. Ray 2D dot force raycast update. There we go. Okay, and so if raycast 2D is colliding, we want to check if it is not colliding, then we can move. So if it is not colliding, we want our sprite 2D to look at global position plus input direction. So what's happening here is we are taking the current position of our player and adding it to these vectors that we have here. And that will determine which direction we want the sprite to change. We'll see this working as we are able to test it. Now we want to create a tween, and this is the best way I have found when creating grid movement, because we want to be very precise, and tweens work very well when it becomes to being moving precisely to a location. So we will create our tween, and we'll do tween property. Oh, no, tween property. And it will be the self, so being this player object or scene. And we want to change the position, and we will take position plus input and this bracket notation direction times tile size, and we will do it within 1 second divided by our animation speed. Okay, and then we want to set a transition on it. So set transition, and we'll do tween dot trans sign, if I could. All right, that is super cool. All right, so we want to make sure we have everything good. We're good to go. Okay, so this line's a little long. We could break it up at the commas. Let's do that. And then let's move over to setting or moving to equal true. And then we want to await between dot finished. Okay. And then var current cell is equal to map dot local to map global position, and then we are going to set the location to be painted. So we're going to map dot set cell 0 current cell, and then we'll have ID of 2. This might be wrong. Let me double check. And then it'll take a vector to integer of 0, 0. All right, and then lastly, we're going to set moving to false equal to false. So there's been a lot of code. We need to check if this is working properly and also if this cell is correct. So one thing we want to check is in our tile map. So ID of 2, so this is 0, 1, 2, so it is correct. And so this should work once we get our process function all tied up, which is going to be really quick. So we want to do if for moving to return and do nothing. If we're not moving, we want to do our last check put. Oh, yeah, we could just do else. No, we'll just do if. It's fine. Last input does not equal stop. We can move last input. Okay. Awesome. All right, so we need to add this player to our world scene. Let's go in here and drag it into our world scene. Let's make sure we're on a grid position. So let's add the grid and let's move this and we'll move it to the center of a tile. Select current. Oh, all right, so what is happening? Oh, so that we forgot one thing. So we have our player, but there is no map assigned, and we'll just assign our tile map here, and we'll hit play, and there we go. And we'll start painting on our screen. So it's not the most elegant. It's kind of choppy with how it's painting, but it looks good for now. Okay, so now this is where the fun part is. Our player and our enemies are similar, but they're also different. The player is determined moving by how inputs happen, but our enemies are going to be determined using an A-star grid pathfinding. And so that's what we're going to be doing. So we're going to create a new scene. Like last time, it's going to be an area 2D. Call it enemy. All right. We want to add a collision shape 2D as well as a sprite. I can type a sprite 2D and make sure that's not a child. All right, save our enemy scene, and we can go into our paint racer, add the red car. Let's make sure we have everything we need. We do. Click on the 2D. We can go here, center, go to our collision shape, and we also want a rectangle on this one. And this one we can set to 16 by 16. Yep. Set the 16 by 16. We also want to add our enemy and go in here. And so let's get to our enemy script. So just like the player, we want an export variable of our map, and it will be a type of tile map. Okay, and then we want an export variable. So this is in case you want to change the size of your cells, and in this case we'll default to a vector 2 of 16 by 16. And then lastly, we will have a onReady bar sprite 2D is equal to $ sprite 2D. So again, we can do it this way, or we can click control click drag and do it that way. All right, one last thing is we want that another onReady variable, but this one isn't going to be a control click, and we're going to call it A star grid. If I can type, is equal to A star grid 2D dot new, and then so that will start our A star grid. We also want to have a variable called target, and this will just be a random. So right now it'll just be 0, 0, but it will be set to a random cell as we work. And so now we're going to use this onReady function to go var used rec is equal to our map dot get used. Okay. The reason we're doing this is we want to know how big this grid needs to be for the A star grid. So that we'll get from our tile map. All right, and then we can go A star grid dot cell size is equal to our cell size, and then our A star grid dot region, which takes in a rec, is our used rec. And then we want our A star grid dot dialog mode, the diagonal mode, which will determine if we're ever going to use diagonals. And since we're just doing left, right, up, and down, it will never do a diagonal. And now we need to go get our solid cells from our map. And so we wanted to go and get the map.get used cells from layer 0, and we want by ID, not use cells, by ID. So we want layer 0 and ID 1, which is block vector 2, and this is the coordinates. So I will explain this a little bit better. So on our tile maps, we have multiple PNGs, and so that's the ID, right? We just talked about that. But then this vector is the cell vector on this. So if there was multiple tiles, this is 0, 0. The next one right here would be 0, 1. And if you went down, it would be 1, 0. And if we went into this diagonal, it would be 1, 1. Hope that makes sense. I will explain it if no one understands in another video, but I will keep on coding. So we want to then update our A star grid, and then take for solid cells in solid cell in solid cells, we're going to loop, and this will be able to tell our A star grid what you're not supposed to pass through. And so we'll set point solid, and we'll do solid cell. And lastly, we want to do target is equal to map dot get use cells by layer 0, and we'll just pick. And so this returns an array, and we want to pick a random one, and then we will call, which we don't currently have, but I will just we'll comment it out, and it'll be move. It's going to be the function, and we need to do this function. So we'll func move. Move. In this case, we're not passing it in a direction this time. We are going to determine the path based on the A star grid. So we're going to get path is equal to A star grid dot get path, and then we go map dot local to map global position. Okay, so hold on, let me make sure I'm getting this all. Why do I have two curly brackets? Oh, curly brackets. Map and then target. All right, so let me explain what's going on here. So we are going to get a path based on our current location and based on the target that we got, which is a random target. Okay? And so we want to loop through each point on the path. So for point in path, we want to first look at the direction we're going, which is our point plus the cell size divided by 2. Okay? Then we need to start our movement through a tween. So we need to create a tween. Create tween, and it's literally going to be almost the exact same thing that we did with our player. So for practice, tween property. We'll do self global position. So instead of position, we'll just do global position. Point plus cell size divided by 2. And the reason why we're doing this is so we can offset the position. And then we want, one last variable I forgot to add in here is our animation speed. And so we'll take that and add that into our enemy. And so 1 second divided by animation, if it is not showing it for me, speed. Okay. And then we want to do the exact same thing, set transition to tween trans sign. All right. And then we will await tween not finished, and our current cell is equal to map.local map global position. All right, so we don't need to type in all this code if you don't want to. It's the exact same thing that's happening here, except instead we are doing the red one. So we want to go and get ID 3 for the paint red. All right, lastly, we want to do target is equal to map.get use cells on layer 0, pick random. So this is going to be kind of cool. We're going to do a recursive function and recall this function. All right. So what's going to happen is we loop through our path and we move, and then when we get to our location, we will get a new target to move to, and then we will move. So let's get rid of this process function, and then let me show you this working. So let's go in here, make sure our enemy is set up 100% properly. We go in and check my, there's a couple things that I need to change. So I'm not sure if this matters, but I centered it like this. And then let me double check the sprite. And the sprite offset is not centered like this, and you move it up. We'll see if this is working correctly. If not, I will fix it and let you know. So let's go and instantiate an enemy into our world. Let's move it to a tile. Let's see if it works. Because we exported the tile map. So let's go and re-add that tile map to our enemy. There we go. Is it moving? It is not moving. What did we do wrong? Let me figure it out. Alright, so the last thing I really forgot about was just this last thing that I forgot to add in, which was the move, to actually call it to move. And then we hit play and it will move on its own. And we'll try to catch this and start pitting over the tiles. Alright, so one last thing is we're not able to kill it, so let's do that. So one. Sorry, I had a cough. So one thing that I want to do is go to our node and add a group, and it will be called player. And I added just player. Add that in there, and then we want to go to our enemy scene and go back to our node and hit signals, and on area entered, connect to this script, and we want to check if area is in group player Q3. So nothing too fancy. It's just telling, hey, if we hit an area that is in the group of player, kill it, and we'll hit play. We'll chase this guy down, see if we can get to him. He's really fast. Okay, so in the paint racer, they made the cars a little slower than you are actually. So let's do that. Let's look at our enemy, and so instead of 10, we'll do 4. Play. Alright, so he's a lot slower now. We can catch him and we can destroy him. Alright, so one fun thing that you could do is go in here and duplicate some of the cars, add them to the grid, and try to chase them. This is kind of the basis of how the game works. We try to get the bit painted over. If you want to see this fully connected and everything set up exactly how the game works, I will make another part to this tutorial. But we're already at 30 minutes, and so I'm going to leave it here. If you did enjoy it, please let me know. If you want to see more of the UFO games we made in Godot, please let me know. I really enjoyed UFO 50, and it's a fascinating game, both in the sense of returning back to the arcade games and how much polish are in those games. Again, if you like this video, please leave a comment, like, and subscribe. Thank you so much. I'm Cosmic Contender. Have a great day.